Hello, in this video I'm going to talk about the method GethashCode. This method can be confused sometimes because according to uh, the type that you are creating, it is going to use a specific method or a specific implementation. For example, I have this class. This is device, and it has two properties, has battery and name. Okay, a device can be a TV, a cell phone, a computer, etc. And it has a constructor to it receives two parameters: name and a specification for a battery, if the device has a battery or not. And okay, this is an implementation of the hash code, but I'm going to remove this by the moment. And okay, in this the class program, in the void main method, I created two devices, a TV, and it doesn't use a battery, and a laptop. And the laptop, of course, they use a battery. Now, I'm going to get the hash code for these two objects, and I'm going to write, okay, console dot write line, because I'm going to get the hash code for these two objects. Okay, first one for the first device, get hash code, and for the second device, that's device number two. Okay, okay. What's going to happen here? As I said, when you declare a type, this type by default is inherit, and the parent class is object. Okay, how we can see that? Very simple. We are calling, we are we are using this method, and if we go to the declaration, excuse me, the definition of the class of the method, you see that the class corresponds to object. Okay, here is get hash code, and for that reason it has a special behavior, and that behavior is that you are going to get the address in memory of that object. Okay, you're going to get the memory address for this device object, and the same is going to happen. It's going to happen here. So if I run this program, we're going to get, of course, different values. It's running. Yeah, we got different values. Even if we use the same parameters, false, TB and TB, false and false, we have different get hash code return values. Okay, that's the default behavior for the get hash code when you declare an object. Another behavior is when you instead of use a class, you use struct. Okay, now a device is a struct, not a class. And if we go to the definition, this method, we see something different. Okay, wait a second. Okay, it's correct. Go to definition again, and as you can see, this is a different class. It is inherit from a different class. In this case, it is value type. So this implementation is different in this case. Sorry, is this? Okay, GethashCode. This implementation is different. And the behavior is different because it is going to use every member of the class, of the struct in this case, and it is going to create a unique value according to the properties of the class. Okay, in consequence, what's is going to happen here is that we are going to get the same code for these two structs, these two objects here. Okay, it's going to be different. We're going to get a different behavior. I'm going to run the program, and of course we have the same value. Okay, that's the behavior is completely different from when we use a class. Okay, and it is useful when you want to compare two objects according to the properties, and you don't have to compare property by property. For example, device.name is equals to device2.name. Okay, it's completely now if I change value of the name, for example, in this case, we're going to get different code. Okay, as you can see, it's different because one member of the object of the class has a different value. Okay, in this case, it is tv1, so we get different code. Now there is another behavior, and it is that if you implement the GethashCode by yourself, okay, you can do that. I'm going to change this to class again, or you can use a struct, whatever you want, and I'm going to write override, and immediately you see the GethashCode because it is on the parent class, and you can create your own behavior. Okay, you can say, okay, I'm going to use the addition, or you can summarize these two values as battery. You can say GethashCode. You can add this value with the name GethashCode. Okay, or you can, I don't know, to use a different operator here, or this operator. Yeah, you can create the code as you want. And well, one more time, we see the GethashCode here, and if you want to know the behavior of this, using this GethashCode method for a primitive. The only thing that you can do is go into the definition. Okay, and as you can see here, it is using struct, and you know the behavior for struct is going to use the value, and in this case name, this is a string. Let's go to the definition, and okay, so you can see the GethashCode here. Now let's see that this is a string object, and maybe you are thinking that it is going to use the address, but it is not in reality, because a string is a sequence of chars, as you can see here. And if we go to the definition of this char type, I'm going to press F12. We can see the struct type here. So we're going to have the behavior of the struct, or the implementation for GethashCode for a struct. It's going to use the value to create the code. Now, if I run this example, we get different codes, okay, because it is using the struct behavior. If we change this to TB again, we are going to get the same number, okay, even though we are using the class type here. The GethashCode is using the struct behavior for the GethashCode in this line. So these are the three behaviors. Okay, I hope it is useful for you, and thank you very much.